All right, we have a pretty good first attempt at this. Question reads, if you invest 5,000 Swiss francs today in an investment that pays 3.25% per annum, compounded monthly, how long will it take for the investment to double in value? So you chose the right formula for this, but you, instead of doubling it, you actually squared it. So 5,000 squared is not the same as double 5,000. That's why you're probably getting a number of years. That seems really wrong to you when you do this. I think you've also done something a little bit weird right here. I'm not sure actually how. Oh, you just multiplied that through. Yeah, if you, this is not actually equal. This line and this line are not actually equal, but that's okay. So let's just try this. So we've got A equals P 1 plus R over N to the NT. Okay. Now, doubling means that A should be equal to 2P. Okay, so we want to double our principal. That means we multiply it by 2. So I'm going to set 2P equal to P times 1 plus R over N to the NT. Now if I divide both sides by P, this cancels, and I get 2 equals 1 plus R over N to the NT. And this is what we expect from the exponential function. It shouldn't matter what our initial value was, what our initial principal was. It should double at a regular rate. Okay, so what you want to do here to get this nt out of the exponent is you want to take the log of both sides, but you want the log to the base of to be the same as the base that you have here. This is your base here, this bit in parentheses. Okay, so I'm going to take the log of both sides, but I'm going to put it to the base of 1 plus r over n. And that's just some number. You know what r is, you know what n is, you can simplify that and calculate it. But it's going to be important that we do this with symbols first, otherwise it just becomes a big mess of numbers. And when I take the log to this base of a number to that base, it's just going to cancel out and equal 1, and we'll be left with this nt. Okay, so we took the log of both sides. All right. Now, we're going to divide by n because we want t, and this cancels and we're left with t. So we're going to get t equal to the log to the base 1 plus r over n, and I know that's getting small, but that's okay, over n, and this is the log of that base of 2. Okay, so now we're just going to plug in our values that we had before. So this is going to be equal to the log to the base of 1 plus 0.0375, and we have to convert percentages to decimals, right, by moving the decimal to the left 2 times, over 12, and that whole thing is going to be our base of 2, and then we're going to divide that by n, which is 12 in this problem. Okay, so I will plug this into my calculator. Okay. And so we need to do a change of base, which you guys know how to do. Look that up if you don't. So we're going to take the log of 2 divided by the log of 1 plus 0.0375 over 12 divided by 12. Okay, so I'm getting approximately 18.5128, okay? But I think they want this in years. So we want to make sure that we round up. Well, okay, maybe not. So it's compounded monthly. So let's subtract 18 from that value, and then you get 0.5128-ish, and so we'll multiply that by 12, and that's 6.15 months. So we need 7 months. We should round up because it's going to compound at the end of that 7th month. So the answer is going to be 18 years and 7 months. Okay, this is 18 years and 7 months. All right, and so just so I can sketch out what I did to convert my 18.5128 to months, I took that 18.5128 and I subtracted, this is in years, so I subtracted it off 18 years, and that left me with 0.5128. Okay, so this is the remainder after I get years, and I want to figure out what that is in months. So I took this number, and I multiplied that by 12 months. Okay, and that left me with something, let me see, I had 6.153 months. But it's going to compound at the end of this month, right? So it's initially like into the first part of the month is when you would have crossed it if it were linear, but you get jumps each month. So we have to round this up to 7 months since it won't compound until the end of that period, which is it's monthly, okay? So 18 years, 7 months. That's our answer.